What I'm most excited about is now I can cancel my health insurance. Dr. Tom, he's got the agent.
Yeah, yeah, I would I'd hang on to that. I'd hang on to that for a bit until you see the effectiveness of my agent.
Yeah, but if you look at the numbers, and what was it? They were getting like 85% accuracy. So even hey, if you're a medical professional, I'm just joking here, but like the percentages weren't that high to begin with, apparently. So
All right, for the demo this week, I thought I'd take a paper that was doing the rounds, which was this paper by Microsoft, or the team at Microsoft, who they work on applied medical AI effectively. And they released a paper where they talked about having a mixture of agents applied to medical cases that outperforms not only the leading frontier models, but also when they get actual doctors to basically evaluate the data set, it outperformed those doctors as well. And I thought, let's talk through that because I found it quite interesting. And then also let's talk through around how could we potentially go about building that in something like LangGraph and LangChain, using LangChain, and then go through the tracing using LangSmith. And then maybe you can give me some coaching in terms of like my graph structure, because there's definitely some things in there that need to be improved. So I thought that could be fun. So did you see this blog post at all?
yeah, I did find it actually really interesting because I have people close to me in the medical field and talk about some of this on occasion. So
Yeah. Oh, cool. All right. Well, what I might do is I'll briefly give people an overview of what it was. So here's the blog post here. So as I mentioned in the intro, they wanted to understand, could they get an AI agent to outperform your standard medical professionals on specific benchmarks, trying to diagnose certain conditions or certain things. And they used publicly available data, and then they used open models that they could get their hands on that were still commercial. So they used models from the leading model providers, and then they also built a specific app to test this. So what they actually did was they created a series of medical challenges. So they got a bunch of case examples from the New England Journal of Medicine. Have you heard of that before? New England Journal of Medicine? Yeah. So here it is here. It's a leading medical kind of journal. Actually, if you go to the website, they've got data sets and benchmarks. There's like an open set that they actually publish here as well of other things that are not the ones based on this research. So they actually seem to be pretty leaning into this sort of open data set, eval set kind of space, which is really cool. And then there are other medical ones on Hugging Face if you go on Hugging Face and look for other data sets. But the specific
this
data
is,
set that's,
I'm sorry,
sorry.
the New England Journal that you're talking about,
Yeah, yeah,
leaning
they
into
actually
it.
publish.
Well, did you know that they have an exclusive deal with Open Evidence now?
I did not know that. So Open Evidence is the startup, right?
Yeah, they've exploded, and I feel like, yeah, I really don't know, but I venture and I'm kind of actively working on something in this area actually,
Okay.
and I feel like it's actually pretty wide open because the Open Evidence is one of the only, I mean, they're crushing everybody, and they have a really cool story. But what's really interesting is that they only became HIPAA compliant like yesterday. I mean,
That's the greatest.
the more I've uh, got into this area, I'm like, I don't think people are even trying, and I can't say that for sure. I know people are, but I know for me initially, it's like that's such a barrier to entry, the medical field. Like unless I knew people, uh, I wouldn't even venture in that area. And I just feel like that's probably how a lot of people are thinking. But I feel like there's a lot of opportunity there.
Yeah, well, if you consider that so much of the consumer level interaction with these AI models is medical or psychology related, kind of cat's out of the bag, right? Like you can't really, it's like one of those things where you would just say, well, there's like potentially hundreds of millions of these conversations going on every day. You know, you kind of have to lean into it and sort of maybe loosen up some of the constraints, I'd say. But you'd want to be, you probably wouldn't want to be one of their backers in that, in that conversation would be a bit scary.
Yeah.
Would be a bit scary. Yeah, these guys are really cool. Yeah, and they've got this New England Journal of Medicine. There is actually a Google model that's available that's similar to this that they have built specifically for medical kind of applications as well. It's like a closed kind of almost like it has more guardrails on it than their regular models, and it's available through Vertex. So there's a few different sort of API products related to that. Anyway, back to this. What they actually did was they got these New England Journal of Medicine case proceedings. So there's in every sort of episode, I guess you'd say, of their journal, there's a very detailed case description of typically pretty rare conditions, and it goes through in very fine detail, you know, what were the symptoms and what were the tests and a range of other data, and then the eventual diagnosis and how it's based on this description, like basically how they got to that assessment. So it's an incredibly rich data set for an eval like this that you would need to test an agent, right? But it had to be transformed. So these guys, they built this specific data set called SB, I believe SB Bench, which hasn't been published. SD Bench, pardon me, sequential diagnostic benchmark of 304, a subset of these cases, 304 of them. And they used that to basically try and figure out if they could create an agent that would then iteratively kind of find its way towards a diagnosis, which was pretty cool. So that was step one. And what they needed to do was figure out, all right, what's the architecture of the agent? What's the agent architecture? What are the actions the agent can take? And then how will that agent be fed information about the case in order to develop its hypothesis around the diagnosis and then eventually make a diagnosis? So that architecture is outlined here on this diagram, which you can see that I'm sharing. Can you see that all right there, Cameron?
Yep. Yep.
So basically, the core model that they used was O3. And then they had a set of O3 models that are prompted with a specific persona. So they had a doctor challenger agent. They had like a checklist agent. They had a stewardship agent that was, you know, kind of overseeing everything. They had an agent that was generating hypothesis, and then they had an agent that would test, that would choose which diagnostic tests should be ordered. And then that was basically this chain of debate function where they all basically contribute just to one state. And then at the end of that round of evaluation, a decision was made from this sort of orchestrating agent, which was like, you need to ask the patient a question, follow-up questions based on the information they have. You could request a test, or you could make it provide a diagnosis. And then there's this other kind of agent that feeds information back to this kind of chain of debate kind of swarm of agents that knows about the case that they're trying to diagnose and can provide them information. And basically what they do is that agent will basically say, all right, well, you know, you've ordered this blood test, blah, blah, blah. Here are the results. Now, those results could either be the real results that were from the actual case or synthesized data of, say, if it wasn't related to the case. The reason why they did that is they found actually if they just provided like, oh, no data found, actually there was a reward hacking function that emerged where the LLM swarm, if you can call them, of doctors realized that, oh, I must not be onto the right track because no data was provided. So they actually had to kind of create this false data set, which I found pretty interesting. Did you read that when you were going through it? Yeah. Like reward hacking comes up everywhere. But essentially that kind of data information or kind of gatekeeper agent feeds back the information that from, say, the requested test or anything like that, or like a question that they might want to ask the patient, and then it synthesizes kind of the response, which I found interesting. Over the top of that, they also had this cost analysis kind of function. Did you read much about that? cost component. Yeah. So what's interesting about the cost component, and I was a bit confused when I saw this kind of diagram here, which I'm showing you, which is sort of too large, but I'll zoom out. When I first saw this, I was like, oh, is there like a computational costs part of this study? But actually it's not. So what I'm looking at here is on the bottom axis, there's basically cost. And on the top axis, there's diagnostic accuracy. So they actually had this like other data set, which was a standardized pricing kind of sheet of all of the average cost of ordering specific types of medical tests in the American medical system, plus a standard $300 fee every time there was a patient consult, which was basically the LLM asking the patient questions. The reason why they did that is they wanted to not only get a diagnostic accuracy of this kind of swarm of agents, but they also wanted to understand relative to standard medical practice with physicians, what's the actual aggregate cost that was incurred by this agent, which is down the bottom here in thousands of dollars. Because obviously every test has a cost. You didn't want an agent just running off and going, well, I'm going to order 50,000 tests just to figure it out. They wanted to overlay some sort of kind of cost constraint, which was a pretty interesting part of the study. Overall, the results are pretty incredible. So you can see basically standard models in terms of when they were trying to use those standard kind of open models to try and get to a diagnostic accuracy percentage. O3 was like the closest to this ensemble that they built, which was basically just prompt engineering. But it was very, very expensive. So O3 just basically costs $8,000 of test like theoretical tests to get to almost 80% accuracy. Whereas this mixed, they're calling it MAI-DXO, MAI-DXO kind of blend of agents could get to 80% accuracy with about $2,500 of test costs, which is pretty amazing. And even just with questions only, so not ordering any tests, it was still significantly more, had significantly higher diagnostic accuracy than, other models that are frontier models when they even got to order tests. So it could get the results or get an accurate diagnosis at 50% of the time just by asking questions, which was significantly cheaper. So it's pretty incredible, really, all from an ensemble of prompts. So just prompt engineering. Yeah, I found it amazing, actually. And then probably why it was causing a bit of a stir online.
Yeah, I was curious what made you become interested in this?
Well, number one, I was like, right, well, that's pretty interesting research. Number two, I loved it because it was just all based on publicly available data and pretty much just stuff that we can build now. So the database for the test costs was open. The question set is actually open from that journal. They just transformed it. And we can just use these models, right? Like they weren't using anything that was custom. It was just O3, what we all have available. So that was what made me interested. The other factor is like, all right, well, how would you replicate this rather than just like this is a theoretical kind of idea. This isn't a product that's available at the moment. We're like, well, how would you build this? How would you turn this into a product? That's actually why I was interested. Like, how could I use LangGraph and LangChain to see if I could build like an interactive version of this that you could then basically turn to other medical requests in a either theoretical way where it just asks you questions, or could you connect it up in the future to like a on-demand kind of pathology service to get, I guess, on-demand medical care for people that was high performance and low cost. Like that that's probably the most interesting thing of this is like there was a cost attributed to these agents interacting with a patient of $300, right? But in reality, it's like cents to interact with O3, right? And O3 is always available. My physician is not always available. Like I'd have to make an appointment. All of those things are constraints on people getting medical care. And so behind the scenes, if this could be transformed into a reliable, medical kind of co-pilot, it's pretty amazing what it could achieve, really, for human health based on this.
Yeah, and I guess in the case study they were talking about like 300 cases.
300 cases,
So
yeah.
I don't know how many this represents, but man, like if it doesn't take a genius to realize the impact. I mean, that's insane. Like, if you
Yeah.
scale this over, like, millions and millions of people, that's so significant.
Yeah. And if you consider how many people there are in the world that don't have access to medical care, right? Where
Yeah.
cents on the dollar, like, or even just being able to get advice is critical. Like, I think we both come from very wealthy countries. The idea that you couldn't get access to a physician is sort of, yeah, there are constraints, but it's not something that is a reality for you and I, whereas that is a reality for billions of people around the world, right? And this basically means if you could make this into a product, it means like if you got electricity, you've got access to a doctor. That's pretty amazing.
Yeah. No, you're absolutely right, and like, we feel the impact or, like, we know the impact or we can speak the impact, but to actually feel that, I mean,
Yeah. So there are a couple of things to call out in terms of like the limitations. So this is the actual paper. So they've submitted this as a pre-paper. They've submitted this to I believe they've submitted it to a journal. And I used this when I was reading through this a lot of the time. And this is where a lot of the architecture comes from. So to get an understanding of how they actually built the architecture of the agents and the swarm and this gatekeeper agent kind of concept. And this is pretty interesting actually. So if you were interested in going through it, you can just read through all of these. I'll put it in the show notes, and then there's more detail on the sequence of how they go between the gatekeeper agent and the diagnostic agent, and then how they basically try and adjudicate onto whether the final diagnosis was correct, all of those sorts of things, and how they built like a confidence score. Apparently, a lot of, and I didn't really understand this too much, but a lot of medical kind of diagnosis is based on this concept of Bayesian probability, where it's just a fancy way of saying you've got the universe of potential kind of reasons why this person may have this condition or these symptoms, and then all you're really trying to do is just knock the least probable variance out until you can make an assessment over a certain confidence threshold. So doing some tests, talking to the person, whatever it is. So that's the mechanism, and it's talked through in detail in here. And then they talk through in detail around the estimating the costs. All of that detail is here. A couple of things to call out. The data set is very rare conditions, right? So it's not a great analogy to what it is to be a real physician, because people wander into a real doctor's office and say, hey, I've got a sore throat and a mild headache, and then a lot of the time it's just like, mate, you're just a little bit stressed at work and you're a bit run down, you'll be fine. That sort of variation isn't captured in here. It's like, this is really, really serious. All of them were really
these are all the
serious things.
yeah, like, the most difficult
Yeah.
diagnosis, right?
So like, it's not a really um, great like to like comparison, right? So that's number one. Number two, it doesn't consider like the cognitive impact potentially on a patient, and these ideas around like misdiagnosis or like potential misdiagnosis. If you misdiagnose someone, how that psychologically can affect them if you put them through a process of like, we're going to do all these tests and we're going to like really go hard for it when actually it might not be something serious. That wasn't really considered in the consideration of the actual physician agent as well, which is something that real physicians would do. All of that being said, the thing that I didn't mention before is that they benchmarked the performance of this agent, this MAIDXO agent, which got across those cases 80% success rate with a $2,500 kind of benchmark test cost. And they tested that against physicians that they recruited to actually go through the cases and try and make an assessment. And those physicians got, on average, 20% result.
That's what I was
So
saying, Tom, is that you with an LL or with this agent, maybe it's not so in the red. I mean, after reading that, I was like, "What?"
But the couple of things to call out, like, so those physicians, they wanted to get a raw comparison against like just what's in a physician's head. So they did it on purpose. That they didn't give them access to Google. They didn't give them access to a network of other kind of medical people that they would speak to. So those factors are not real as either, like in real comparisons. Whereas a doctor in real life would like they would talk to their, you know, if they're junior more to their supervisor, they would go and consult with their colleagues. They would go and find a specialist. All of those things. Plus, they would be enabled probably with these Copilot tools already, which a lot of them already are. So that 20%, it probably shouldn't be like, oh, it's 20%, but it may actually be like maybe it's 50% or maybe it's 60%. But even at those levels, this agent swarm is, well, I wouldn't call it a swarm, this agent solution is pretty impressive. Cool. Did you have any other questions on the study before I get into the demo?
Are you going to cover anything about the evaluations? Because I expected to see like like an entire paragraph, and unless I'm skipping past, I barely see anything about evaluations. I thought that was interesting.
The eval set, like when you say evaluations, what do you mean? Yes,
Well,
SD
they're running
benchmarks.
these tests, right? And so, well, I guess they have the answers, right? So maybe.
Yeah, I guess like the eval in this, because the methodology in this is like an academic paper, so it's not a product, right? The eval in this context is the SD bench data set
Oh, duh.
comparing
Yeah.
between the physician and the agent. Whereas probably what you would want in an eval set for a product like this would be very different, right? So I guess the methodology is an eval set against this, using the eval set against two solution approaches, as opposed to like the other way around. Just like I have my eval set that I'm benchmarking against like live examples or optimizations within the product.
Yeah.
Um, cool. So what I did from there is I took this blog post and I took this paper and then I said, what would it take to create a version of this in LangSmith specifically? So LangSmith, sorry, not LangSmith, LangGraph, which we have talked about before. And Cameron,
LangSmith.com.
yeah,
You get to LangGraph, you're LangSmith.
yeah. So LangGraph being the agent design engine from LangChain, which you can connect up to LangSmith to observe, which I'll show you in a moment. And I was inspired by your demo last episode to give this a crack. So I partnered up with Claude Code to do this. And I think probably the best thing I did, or that I should show you, is I started with Claude Code in basically in a new. So if I get out of there and make this a bit larger so you can see, does that look okay?
Yeah, much better. Thank you.
So I've got my LangGraph, blah blah here. I'm going dir Claude example. So, and then I basically just went to Claude, spun up a new version of Claude, and all I did was I said, I want to replicate, this is as simple as it was, this study agent structure using LangGraph, LangChain, make it usable as a chat. And because I'm all about the TypeScript, I use JS TypeScript. I don't know. Do you use Python or do you use TypeScript?
Well, you can't run Python on Cloudflare. So, well, now you can with containers. Can't now you can, but yeah, JavaScript primarily.
So, all right. Here is the paper and blog post. So there was a few other things that I like. It wasn't exactly this simple, but it was pretty close to this. And then I just kicked it off, right? So we might come back to that, but you can see it sort of, goes and fetches a bunch of stuff, and I might just put it into auto accept. Have you seen it? There's planning mode as well. Do you use planning mode much?
I
So
don't. I haven't initiated it. It just kind of does it on its own. I haven't even
Mm.
seen that as an option. Is it?
Yeah, if you press Shift Tab, you can cycle through. So basically, it's kind of like in Cursor where you've got like Ask versus Agent mode. I don't know if you've seen that, but like this is basically like it's basically a way of saying to Claude, don't change anything, just research, or you can go and research. This is in the CLI, obviously.
Now, did you add? Do you have MCP tools?
I don't. Oh no, I've got Playwright, I think, or Puppeteer maybe, but that's it.
So it has like internet basically.
Yeah. So cool. And then it, picks up that it's going to create agent interfaces based classes for 5 specialist roles, implement the chain of debate, orchestration logic. Yeah, so it's pretty good. So yeah, I was kicking this off. It was a bit of back and forth. When I actually was building the version I'll show you next, I got it to stay in planning mode and then update its Claude MD file with the entire plan and then go for it. So I can leave that going while I skip over here if you want, but it's probably going to require me to come back and just do all this stuff. So I can probably just exit out of that anyway. So I'll just interrupt it. Here
Claude
is
Code is not supported on Windows, apparently.
What? I did not know that.
Yeah, when I use my Windows computer, like while we do this podcast, so I was trying to install it. It says it's not supported. That's
Claude Code. That's strange. I think yeah, okay, it's interesting. So here is the very, very long Claude Code kind of message interaction. But what I want to take you through and show you is this is the actual app that I built, and it's on top of, me and Claude built it. It's on top of the LangGraph starter kit. So you can go to GitHub and just fork that and basically adapt this. So you can see it still has the React agent built inside of it. But what I was very impressed by is how well Claude can actually interact with LangGraph, and LangChain. I was surprised. Didn't take too many kind of re-edits or changes to the actual code to get it to work. That was number one. And that's not what I expected. I thought it wouldn't be as well kind of known to Claude. It's number one. I don't know if you've built anything like that.
I asked about tools because that is impressive. If you're essentially doing it like out of the box.
Oh, it has web search, so it can traverse the documentation, and then I pointed it towards the deep wiki recommendation. The deep wiki documentation.
Well, yeah, that makes sense. Yeah.
Yeah. But even still, I was pretty impressed. So basically what it did is it created an initial case assessment process in the diagnostic flow based on that documentation. So taking the medical cases input, and it created kind of test cases as well. Then it created these 5 specialized physician agents to debate on the case. I had to get interrupts added in there to make that work. And then basically from an interaction with the patient, it generates dynamically 3 to 5 specific follow-up questions based on the diagnostic gaps that it identifies between what the patient said, so in this case me, versus its the probability standard it's assessed based on how confident it is around its existing diagnoses. Remember, this is all from a 1 or 2 shot Claude coding. Most of it is just prompt engineering. It's incredible, really. Yeah, basic chat interaction. I would like to put some voice over the top of this, but it's currently just in chat. Once it gets that, it takes that information back, puts it back into this chain of debate medical kind of cycle, and then it returns through that process. A couple of things I had to change. I basically had to go in. Oh, you can see here, and these are the physician team kind of structures that it put together. Doctor hypothesis, doctor test chooser. It did build out the test chooser functionality, but that's not hooked up to a database yet. So that's in the plan that Claude developed in the MD file. Then there's this challenger, which identifies the existing biases. Then there's the cost controller agent. and then the quality control kind of oversee of the entire process, kind of some sort of, have we covered everything? Are we doing the right things, etc. Yeah. Then a couple of things I had to kind of tweak in the process were making sure that when its confidence level on the diagnosis was above or beneath a certain threshold, make sure it went back and did more turns with the interaction with the patient, and then forcing it to do at least 3 turns of engagement with the patient. So it was basically just talking to me once and then saying, you've got angina, whatever, you're having a heart attack. So it was actually not kind of discovering enough about me and about what was going on. Everything else was out of the box. And then these standard, example generated questions, which is basically just few shot examples on the prompts for what we were just basically the medical case. Everything else is standard. So I did push this to GitHub, which we can share, and you guys can play with it if you want. Here, this medical diagnostic agent, that isn't updated, but it has all of the kind of flow. You can play around with it, play with the different settings. Cool. Do you have any other questions on the architecture before I jump into the design?
So everything you've covered so far, it did without any additional intervention, just from the initial prompt. I mean, you mentioned a couple little things there, but
probably 4 or 5 things, plus a couple of catastrophic errors that were introduced that I had to debug. So it was probably maybe like 10, but a lot of the architecture was one shot. So this stuff I didn't change at all. Like, how it turned, like the turnaround on, like, how it interacts with the user. The initial interrupt triggers, I just changed those once I was testing it. And I did that manually in the code because it generated like a configurator automatically. And then these I didn't change at all. So the methods that it took from reading the paper and implementing the prompt structure into the physicians, I didn't change that at all. And these, like probably 70% of this stuff, was initial build.
Yeah, that's amazing, isn't it? I mean,
it is amazing. It's absolutely amazing. The other thing I started adding extra features. So I've got a couple of feature branches running on this. I added like a Bayesian engine probability modeling kind of thing on top, which I didn't actually add that. It was actually outlined by Claude in the Claude MD file. So my approach with Claude is I basically say, start in planning mode, build out your plan in the MD file, then come to me, which is a pretty standard pattern, right? And then I can start approving the sections. And then as you move through the sections, we create a new feature branch, and then we merge that back into master. Where is the? It's not updated. It's in the README.
Did you put this on? The GitHub? The build GitHub.
Do we have a build GitHub?
Yep. Yeah, you're an owner.
Am I? Oh.
Well, yeah, I know we've set up like every system there is. Here, let me put it I'll put it in Teams for you.
That would be sick.
I've been putting any of the demos that I've done. I don't know if it's all of them, but I've been trying to upload things there. So it's at least if it's relevant to what we're talking about.
Yeah, I will. I've got it just on there. I'll push it after this. All right. So a couple of other things to highlight. There is effectively what it built was this chain of debate. Let's hide this panel. There's basically like this chain of debate structure where if you look at the original paper, what it basically did was try to replicate this cycle here, how these agents interact with each other. And all it did was basically just put it into one state, right? You could probably give me a sense of like actually how this varies compared to, say, a node that's its own sort of agent that passes back. Basically, this is all within one LangGraph node, and it's all held within this like medical state kind of concept where they just pass it back, effectively like fight it out, and then decide what to do next within this chain of debate kind of class here. And if you look at that down the bottom here, orchestrate. So there's this orchestrate debate between all of these agents. Well, they're not agents, they're just LLMs with a specific kind of prompt on top. And then they go through a certain number of rounds. So medical diagnostic round, executed debate round. And then I could configure how many rounds it goes through on every time. And I haven't actually looked at this, but it'd be interesting to see how these guys are structured. You can see all the different like execution modes here, where they actually have, I believe it's...
Didn't you have it in LangGraph Studio?
I want to pull that up, but I just want to look at the code a little bit more, because I realize when we do these demos, we don't talk through the code enough, and I'm just like, all
Yeah,
right,
that's a good point. Yeah, I should.
always let's just like jumping through to the main game, which is LangGraph Studio. But yeah, here it is. So here are the roles. It chooses the different physician roles, and literally it's just a customization of their system prompt. And it generated all of this system prompt on the fly based on the medical paper that I fed in. One of the reasons why I thought this was interesting is, obviously, number one, like this was pretty fast and it's actually pretty good. So when I go through a demo, you'll see. But number two, like how many other things are there like this where we could just generate like a mixture of, I don't want to call it mixture of experts, but I don't really have another word for it, because mixture of expert kind of prompts architectures around a problem set that we could develop very quickly. So kind of like using, what I want to do after this is use the assistance feature. Did you see that from the LangChain guys, where you can basically take an architecture and just change the prompts? So it could take this from a general physician kind of application to a skincare doctor, where it's like dermatology specific things, or a psychology specific thing, just by updating these on the fly.
Like an abstraction.
Kind of like, yeah, you've got the architecture and the architecture works, and then you just update the specialist prompts to apply it to a different subject domain. And you can actually create assistant versions in LangGraph Cloud to do that now, where you're just like basically updating the system prompts, but everything else remains the same.
Yeah, exactly. Like your tool set, what tools are available,
Yeah.
RAG, the assistance stuff is actually really cool.
Yeah. So you can see, yeah, that's the cost doctor and his basically cost considerations. Claude put a default cost cap of $1,000 just by default, which was incorrect, but I didn't change it because this cost chunk isn't implemented. And then this is the checklist one. So primary responsibilities, verify the completeness of the diagnostic workup, all of that sort of stuff. It's actually, yeah, it's really cool. It's really cool.
Where's the insurance agent? That one would be easy. It's like that'd be an easy one. You need like,
yeah. Denied. All right. So what it actually looks like in practice is here. Now, there were a couple of things to highlight when I actually did load it up. So this is, I've been doing a couple of rounds in here. This is in the LangGraph Studio. There's this start mechanism and initialization, and actually the graph has many references back to the initialization, which sort of doesn't make any sense. So that was one of the updates I had to do, because basically it was initializing the case, it would debate it out, I'd get an interaction, it would come back, and then it would overwrite everything by default and get stuck in a loop. And so there was no kind of new information.
You had to add the interrupt.
I had to add the interrupt, but then I also had to get the solution was actually to add in like ignore if the case is, the same and have a case ID. Whereas actually what I really wanted in the architecture was just like that initialized case just is never there, and it just always goes into the medical debate. But that is actually pretty helpful if you've got like multi-turn, user interactions, I assume, where maybe someone's coming back or they're working on a different case, like sort of makes sense. But it also makes it super messy when you look at it in this graph diagram. But here is the medical debate kind of engine, where you can see it has access to the diagnostic tools and patient interaction, and then the target is patient interaction, diagnostic tools, and then the final assessment. When it goes through its final assessment, it can then, the graph ends effectively. So what I might do is I'll start a new instance of this. So these are my different threads, a new thread over here. And then if I check out, let's check out all these different inputs. So these are all the different inputs that it's got available to it, available case info, diagnostic tests, the cumulative costs, all of these different kind of variables or input components that come out of it. And then in the initial message, there is actually a example case in here that was generated in the tests. Medical agent test. There we go. So that's like a test case that Claude also generated on the fly to do the testing, which was also really cool. And chuck that in here. Oops. And then we kick it off. All right, so that initializes the case. I'm a 55-year-old male, presents with chest pain, shortness of breath. For 2 hours, pain is crushing, radiates from the left arm. Still sounds very, very serious. And then you can see the medical debate kicks off here. I'll just zoom in so we can just focus in a bit on this and you can see where it's going. And change it to maybe the preview. You are right. It's quite hard to get a sense of what's going on here. So then it starts with initial consideration. So this is a bit of a constraint on the current architecture. I probably should change it to basically just say, all right, we'll just ask the person more questions up front, but I kind of wanted to see what it would do. And you can see it kicks off its primary and secondary considerations. And then you can see from there all of the different chain of debate functions kicking off. So here is the biases kind of agent, if you will, or sub-agent as part of the medical debate. And it's kind of looking for contradictory evidence, these sorts of things. And this was, it was these elements that just prompting that it looks like gave them that boost of performance, which is incredible to consider, really. And it
No
makes me
tool
think.
whatsoever.
Sorry?
So there are no tools involved whatsoever. It's pure LLM prompting, right?
At that point, yeah. And also, if you remember when I was showing this part here, it gets to really high performance just by asking the user questions, like without any kind of ordering of diagnostic tests or whatever. It's literally just, there's something about the reasoning potential of having these comparative kind of divergent perspectives. So now it's gotten to here. You see the medical debate. It's not ready for a diagnosis. Its reasoning kind of quality has benchmarked itself as like out of 1 is 0.38. And it's up to debate round number 2. So, and its confidence level on its diagnosis is currently 0, but it has a 0, cumulative cost of 0. And then you can actually dive into each of these components and see where it actually got to and what it actually, like the decision set effectively that it got to across all of those different things. Then it's come back to me for a bit of patient interaction and it's waiting for my input. The interaction round is number 1. I've benchmarked it to say it has to get to 3 rounds just because I wanted to force it to do that. And then it has these pending questions. So it has generated default questions. So here's one: do you smoke, or have you ever described, or can you describe your alcohol use and also your occupation, et cetera, et cetera. These all came out of that chain of debate reasoning kind of turn between them. And it was generated off that few shot example prompt that I showed you before, right? So if I go over to the chat and say, all right, here we go. 1, yes, a lot. And I work in a coal mine.
Black
2,
lung.
I tried to confuse it when I was testing it. I had an example case where it was a woman. It was a man. And then I just said, I'm a 55-year-old man and I think I'm pregnant. And just watching it go through the reasoning, like, and trying to overcome the conflicting information, and then the confidence like level just going like, well, we don't know what's going on, and then coming back, and actually it was very good. It was like, well, obviously it came back with like a psychosis or a psychological problem.
Did it really?
yeah, that's what it showed in the reasoning chain. Obviously that wasn't presented to me in the chat,
That's
which I thought was pretty impressive. 2 hours. And it is very, very bad. 9 out of 10. 3. All right. Yeah. No. Yes. Yes. I have high blood pressure. 4. What is it? Yes. They all do. and we'll see what this does with the confidence level. I take statins for blood pressure. I'll see. Now, I had a couple of problems with this before. Maybe it'll be something you can help me with. Push that back in there, and then I should get an interrupt. In this instance, Cameron, I just write resume, right? Correct? Or
or true. You
true.
you can put true, I think.
True. Now we'll see. I had to debug that for a while, and it wasn't really working.
Do it without the quotes.
Without the quotes. Okay, let's see what happens. I think it is kicking off, but then it's just really slow. While that's happening, I might just go over to LangSmith and see. We can have a look at it in LangSmith as well. Because it is, you're right, it is a lot nicer to look at it through here. And this is the tracing of user responses. It's not ready for diagnosis. It's also incredibly slow when you use O3 for this sort of stuff. I found that it's just like sits here for a while and then eventually will just kick off again. If I go into my monitoring, it's in here. You can see the amount of time.
Yeah, building agents. I run into that actually all the time. Earlier today that happened where I'm like kicking the thing, like hitting refresh.
Yeah.
And then all of a sudden it's off to the side. I'm not even paying attention and it just pops up. I'm like, oh.
It just kicks off. Yeah, this one does the same. So you can see there like latency is like average latency is 153 seconds. So it's really, really slow. I'm using O3 for every single call. Whereas optimizing this would be, for the engagement or the interaction or passing the data, it would be like Flash or, GPT 4.1 or something like that. This should be, it's working here now. All right, cool. So you can see it's like chain of debates kicked off again. So from here, the hypothesis has come back with everything that I've talked about and my response. Okay, great. And then if I jump back into LangGraph, here we go. Medical debate. Yeah, here we go. The debate continues and it's already come back to the patient for the follow-up. So number of agent turns, where is it? The challenger, recommendations, biases identified, reasoning. Here's the reasoning here. And then it's obviously requesting. So you can see here, it's like they're requesting, all right, has an ECG been performed? All of these sorts of things. Remember, like none of that was programmed in. All of that is just default O3 behavior, right? That's the other thing that I find incredible about this. Now, we're not doctors. Like I'm not evaluating this as to the accuracy, but this is exactly how this study would have been structured and how they did it, right? And this is the result. And then they compared it against the performance of actual doctors. So it's kind of inspiring because it enables developers to step into spaces that in the past have been very challenging for them to step into, provided that you've got the ability to benchmark against high quality data sets and, have oversight from professional experts. Whereas it would have been very challenging for you to do something like this in the past.
I would be interested, like you just had open evidence, and I'm not trying to make this a open evidence commercial, but I would be curious how they compare because they have been training models on like PubMed and for like the last year, I believe, New England Journal recently. So
right, yeah. I would be interested to see how. I would be interested to see how it compares with a fine-tuned model. What I find fascinating is that is fine-tuning better than just great reasoning? And this method that they show, which is basically a version of, now this model that I've built is not exactly the same, but it's a version of, which is the chain of debate, right? Effectively, it's all kind of happening within here. Chain of debate, improved context, more data, et cetera, and they define this kind of like structure around the 5 as the best way or the way that they wanted to do it. That surely must go on to be or will go on to be features of reasoning models that are being developed in the background, right? If you imagine like this performance boost here around diagnostic accuracy, if it's as simple as just architecting the internal reasoning chain for these models as assuming personas around a certain use case, that must be something that is in development around how these models are being developed to improve their performance around reasoning, which means, if that is true, would it be better just to improve the reasoning chains as opposed to building custom models? Because we've already got like the Rolls Royce of like reasoning over here with O3, as opposed to going down the rabbit hole of customizing and fine tuning, a custom agent. I don't know the answer, but that looks pretty promising to me. If this plays out across other domains. What's going on with my chat? All right, I might just jump back into the chat and then I can call it a day on the demo. Unless you got any specific questions, you want me to jump back into? Where's my chat? Here's my chat. Cool. Or maybe I haven't done this round yet. True. Here we go. You're saying just true. Resume. Okay, cool. Yeah, so there's the next round of questions, and on it goes. Yeah, that's it, man. It was a lot of fun. I'll update that on the GitHub and share it, and you can play around with it.
Yeah, dude, it's super impressive. Like the fact that you're talking about like thousands of years of knowledge, and it has to be so precise. It's so difficult of a problem, and you, like, not a medical professional, as far as I know. You're about to be mine though, and that you basically can replicate like a team of people with you just paste it in some couple things, have a general understanding, and it's like incredible.
It is incredible. It is incredible. Now, a couple of things. Obviously, that hasn't been battle tested, but it wouldn't take a long time to battle test that. But it's enabled by the fact that, say, I can plug it into, in this case, you and I are more familiar with, and we work with LangChain and LangGraph. I can plug it into an engine that is an agentic kind of architecture framework relatively easily with AI developer tools, and then observe it and iterate on it pretty quickly, which isn't something that they talked about in their methodology. So I don't know if they rolled their own or because they're with Microsoft, they used Microsoft's, framework, whatever it was. But I think that is enabling. And what makes me excited about it is like you could go to so many of these studies, right? Ones that don't even involve AI. You could go to a study that was like this in social science where they used, available data sets and go, all right, just plug it into Claude Code, play with it for 2 hours and see if you've got a workable kind of agentic solution that can significantly outperform like a standard experience someone might have with a service or a product. Like that's really cool. Like that's really exciting, particularly given that all of that data was available for free. It's all available there. You can download LangChain and the open source packages, and you can use Claude Code or OpenAI. It's relatively cheap. Like it's unbelievable. This age is incredible based on that experience. Like that was like an hour and a half of work or something like that. Like it's unreal.
I agree. I don't think a lot of people understand. I mean, a lot of people do, of course, I'm generalizing, but like the amount of overhead costs that have just been eliminated. Absolutely nuts. Like so a lot of the things I'm doing in the cloud would have costed like hundreds of thousands. I mean, so much money, and it's like nickels.
Or even if, because I've built a couple of enterprise software apps and businesses in the past. If someone had have come to me and said, all right, Tom, you're a product manager, and this is the app that we're going to build, like that medical assistant in 2017, I would have said, give me $10 million and I might come back with something that might work. I have no idea. Like I legitimately would have said that. And now look where we are. Like that's amazing. Like it's an amazing time to be alive if you love software. That's all I have to say.
Right.
Yeah. All right, man. That's all I've got this week, but that was fun. Hopefully you enjoyed it. I'll share the code. Maybe you can improve it and get rid of that.
Yeah, that's
Prove the
awesome.
graph
And
for
actually,
me. I need you to prove the graph. That graph is really ugly and I need it to look beautiful.
yeah, we got to figure out a couple things, but we have a hosted instance of quite a few things actually, like Open Agent platform. I was going to say, oh no, it has to be the same key. I don't know. We should try it. I was going to say you could send me that graph ID, and I can add it. I can add it into OAP.
Yeah, I've just got to merge this thing, this Bayesian engine, the probability thing that it added. I've got to merge that. Once I do that, I'll update it. I'll send it to you. Yeah, it's sick. Look at me. I feel like a developer. This is great.
You are. You've been lying this whole time.
It's all a ruse. I just memorize keywords.
If I
All right,
called
mate.
you
This was a
out,
lot of fun. I'm gonna go.
yeah.
But yeah, great episode of the build. That was a lot of fun. See you
Oh
next
yeah,
week.
man. I'm impressed. And I was unexpected, and that's always good. So, like I did when you sent that to me, I was like, is this the right
That
chat?
wasn't a complete shit show. I'm really impressed.
No, that was really really good, man. Um, really good.
Oh, that was fun. That was good. All right, mate.